Okay, so in today's lesson, we're going to look at Newton's second law of motion. So basically, force equals mass times acceleration, or F equals ma. And it's for constant mass and constant force. Okay, so variable mass and variable force are not things we're going to consider. It says we're not required to resolve forces at AS. Okay, so we've got to be able to do that, and we've got to be able to do it in terms of simple case of forces given us 2D vectors, so we've got to do it in our i's and j's as well, and restricted forces in two perpendicular directions, so just up and down and left and right. And so let's get started. So Newton's second law, said properly, is the force needed to accelerate a particle is equal to the product of the mass of the particle and the acceleration produced. Now on, I'll just be saying F equals ma. And SI units are newtons, kilograms, and meters per second squared. And that means that F equals ma is 1 newton equals 1 kilogram is the same as 1 kilogram accelerated as 1 meters per second squared. And then gravity is acceleration. Acceleration due to gravity is what causes weight, and so your weight is equal to mass times gravity. Gravity is just acceleration, and it's 9.8. For us, you might use a slightly different one in physics. You might have it as 9.81. You might sometimes have it rounded as 10, but we use 9.8 in maths, so just get used to that one. And obviously, if we were somewhere other than Earth, gravity could be different, but we're considering it to be 9.8. Okay, so another piece of convention is that when something's accelerating and you want to indicate that, you put a line with two arrows on it, and that's acceleration. And weight is a force, not to be confused with mass, which is just mass. Okay, so let's look at an example. Start off nice and easy. So find acceleration when a particle of mass 1.5 kilograms is acted on by a resultant force of 6 newtons. Just use your F equals ma formula. So force is 6, the mass is 1.5. They're already in SI units, which is great. And then A is the unknown. Divide both sides by 1.5 and you get acceleration is 4. It's as simple as that. Okay, so look at another example. So in each of these cases, there's two separate questions here. They're not to be sort of combined in a single question. The body is accelerating as shown. Find the magnitudes of all the unknown forces, x and y. So you've got this one accelerating to the right at 2 meters per second squared, and it's got a mass of 2 kilograms, and then it's got all these different forces. So y and x are what we're looking for, and it's got 4 newtons going this way, and it's got 2g going down, so that's 2 times 9.8. Okay, so if we just consider horizontally, then we know it's accelerating to the right, which means that x is going to be bigger than the 4, which means that the resultant force is going to be x take away 4. If it was traveling in the other direction, then it would be 4 take away x. Okay, so that's how you know which way round to write that, but that's going to be the resultant force horizontally. Force equals mass, which is 2, times acceleration, which is also 2. They're both given to us in the question. So F equals ma, and just rearranging that, because this bit's equal to 4, add on that 4, you're going to get x is 8. Then if we have a look vertically for y, so it's not moving vertically at all. There's no acceleration. So we're going to put y take away 2g. It will work out the same if we put 2g take away y. It's just more convenient to put what we're looking for first. So force is y take away 2g, because that's the resolution of y and 2g, equals mass, which is 2, times acceleration. It's not accelerating, so it's 2 times 0. So this bit 0, spit moves over to the other side. 2 times 9.8 makes 19.6 newtons. So you've got the forces of X and Y. You can do the same thing for B. The only little difficulty here is it's accelerating away from X, so we've got to be careful there, and there's an additional force here. Okay, so in this case, because it's accelerating away from X, 80 is bigger than X, and the resolved force would be 80 take away X. So force, 80 take away X, equals mass, 4, times acceleration, 2. If you rearrange that, it's going to be X is 72 newtons. And then the next one, we have got no acceleration vertically, which means that we'll put Y up front because it makes our life a little bit easier. So Y, and then these two forces are opposing it. They're going in the opposite direction. So Y take away 20, take away 4G. There's the force equals mass, which is 4, times acceleration, which is 0. Rearrange that, replace the G for 9.8, and you're going to get 59.2. Okay, let's look at one more example. So a body of mass 5 kilograms is pulled along a rough horizontal table by a horizontal force of magnitude 20 newtons against a constant friction force of magnitude 4 newtons. Given the body is initially at rest, we're going to find the acceleration, distance traveled after 4 seconds, and the magnitude of the normal reaction. Before we do any of that, what you need to do is draw a diagram. What I think it's a good idea for you to do is pause the video now and try to draw a diagram to represent this. And then I'll show you what the diagram should have and what the answers to the questions are. Okay, so pause it now. Okay, so this is the diagram you should have. So it's a body of mass 5 kilograms. There's your box, 5 kilograms. It's being pulled along at 20 newtons. Friction is 4 newtons. You might have drawn the arrow a bit closer to show friction's acting between the object and the surface, but you should definitely have it opposing motion. So whatever direction you had the 20 going in, the 4 had to go the other way. Then mass times gravity, because the weight is acting down, so 5g newtons acting down, and then my reaction force acting up. And it's being pulled along this direction, so that means that the acceleration, which I don't know, we can just call it A for now, but we'll have some arrows pointing that way. So force is going this way, acceleration going this way with 2 arrows. And it's also important to realize for 2 reasons. So we know that the 20 newtons is pulling it along. That's one way we know it's accelerating this way. And also, friction always opposes it, so we know it would be going in the opposite direction of friction. Drawing the diagram is the hard part, really. Once you've got that, it's pretty straightforward to get your other answers. Because we're finding acceleration, it's force equals mass times acceleration. So force, so it's this 20 take away the 4, if we resolve horizontally, is equal to mass 5 times acceleration A. Rearrange, you're going to get 3.2 meters per second squared. The next bit's asking for the distance traveled after 4 seconds. This is a constant acceleration because the friction is constant, the 20 newtons is constant, the acceleration is therefore constant, which means we're going to use Suvat equations. So if we use Suvat equations, find the distance traveled after 4 seconds, you can just write down your SUVAT and figure out what we know and what we don't know. We know it started at rest, so U is 0. We know that we're looking at 4 seconds because the question tells you. You know the acceleration is 3.2, and so we're looking for S, and this is the best equation to use. We don't know what V is, and so we're going to pick the equation that doesn't use that. And then if we substitute the numbers in, you're going to get 25.6, and it'll have moved 25.6 meters. Then the last one is the reaction of the normal force. So F equals ma, force equals mass times acceleration. The force acting on it is the difference between the reaction and 5g. So if we have a look at the thing, this is going in one direction, 5g is going in the other direction. Equals mass is 5, times acceleration 0. It's not moving vertically, so the acceleration is 0. which means that rearranging that, R is going to equal 5G, G is 9.8, the normal reaction is 49 newtons. Okay, so there are your examples explaining how F equals ma works. And what you need to do now is exercise 10C. Check your answers in the back, submit them in the usual way, and ask for help if you need it. Okay, but that's everything we're looking at today.